Okay, now let's continue from our yesterday's class. So we have discussed the cases where we have n factorial, okay, the n factorial thing. Then we have a times b times so on, these situations. And then we have a raised to power n cases. Okay? And we have discussed how to relate this NPR and then this NCR. Okay? And I tried to convince you guys that this NPR is basically NCR times R factorial. Okay, I'll be starting from this relationship between NPR and NCR uh, so that we can go on to the exercise 5C. Okay, but so see when you have to choose and then arrange 3 items out of 5 items, you can directly do it as 5P3. Okay, and the second way is you can choose those three first and then you arrange them and then you arrange them. Okay. If you people do it like this 5p3 divided by 3 factorial, and that is going to be equal to 5c3. Now this means that now this number is going to give you only the number of choices regardless of their order. Okay? I'll start with an example here and then we'll go into the exercise 5C. Now, suppose you people are, one of you is Pakistan's cricket team's chief selector, okay? And you have, let's say, 10 batsmen available. There are 10 batsmen, okay? And you have to choose, uh, you have to choose um, 5 of them, let's say, or 6. You have to choose 6 out of these 10. So you will simply be finding 10C6. But suppose if you have to choose 6 batsmen with an appropriate or an um, effective batting order. If you people follow cricket, you must know that a batsman can be an opener. It can come 1 down, 2 down. Like there are different positions. That is called the batting order of your team. Okay. So if you have to consider the batting order while choosing these 6 batsmen, so then you will be finding 10p6. Okay? And for example, you have found 10p6, and then you see that, okay, I don't need the order right now. Then you will be dividing that by 6 factorial because you only need to know that what are those batting combinations, okay, not the batting orders. Okay, now the combination means, for example, you have a b c, or you have c b a, or you have a c b. Now these are 3 different permutations, but all 3 of them are representing one single combination. They are representing one symbol combination. Okay. From here, telling you that if you want to ignore, if you want to cancel out the number of arrangements, you divide those numbers which are being arranged. You divide this 10p6 with its factorial. Okay. Now, having said this, let me take you to the book. Okay. And we'll start with the questions. Okay. Now look at this. You have this says find the number of distinct arrangements of all the letters in these words. Now this is table. So you see there are 5 letters in it. So how many distinct arrangements of all these letters we can have? So that would be simply if you do this part A, so that would simply be 5 factorial. One A's answer is 5 factorial. And let me tell you, this 5 factorial is same as 5p5. You can check this from your calculators that 5 factorial is same as 5p5. It is 5p5. Okay, and please, for God's sake, you keep on asking, you keep on interrupting, you keep on stopping me if you have any problem, any issue. Please do not let anything go off, okay, or go away. Okay, so is that clear that I mean, for these 5 letters, the number of distinct arrangements is going to be 5 factorial? Hmm? Yes. Kubi, Alina, is it clear why it is 5 factorial?
Yes, sir.
Okay. Farheen, is it clear to you, beta?
Yes, sir.
Okay. मेरे बच्चों, these arrangements of these 5 letters is exactly the same as we were discussing yesterday to interview 5 people, okay? Or to do 5 different tasks in different orders. So that is going to be 5 factorial. Okay. Now you look at this tablet. Now there are 6 letters, but um, the T is repeating, okay? Now, I can use different colors to explain this to you. Now, suppose you have it like this. Mm, this is going to be tablet. It is like this, or if it is like this. Now, I have used 2 different colors to write this T. Like, the red T is in the beginning and then the red T is at the end. Now, are these 2 different words or 2 same words? Yes, come on.
Same words.
These are the same words, okay? I just use this different colors to make it clear. So when you're arranging them, because of these 2 T's, all the number of arrangements would be doubled. Yes or no?
Yes, sir.
Now, for example, you arrange it like this. Let's say this is going to be, and then you have this, sorry, and you have this here, and you have this here. So again, like, these 2 are coming at the end. The word is same, but this is showing as 2 different words. So therefore, when you find this 6 factorial, this is going to be 6 factorial, you will have to divide it by 2 factorial because of these 2 same letters. Okay, they are of the same colors, these are same letters. Just to make you clear, I have colored them differently. Okay, so these are basically, I mean, you just take it like this. So because of the 2 T's, you will have to divide it by 2 factorial. Okay, now tell me how many words, how many distinct words you will have in this part C.
9.
6, 7, 8, 9. So that is going to be 9 factorial divided by, there are 2 M's, there are 2 T's, and there are 2 E's. So that will be 9 factorial over 2 factorial into 2 factorial into 2 factorial. Yes? Yeah, please object if there is anyone. You must be crystal clear about these because these are very, I mean, complicated, tricky kind of riddle type questions coming ahead. Okay, if you're clear, then tell me about these 2, the D and E part. The right answer for this is going to be, there are 11 letters altogether, okay? And then you have 4 times S, this is 4 factorial. Then you have 4 I's there, this is 4 factorial. And then you have 2 P's there, so this is going to be 2 factorial. So 11 factorial over 4 factorial into 4 factorial into 2 factorial, okay? And Next, E part. Yes, Mehreen, you are quite right for this. Resham, can you tell us about the E part? Hmm?
Sir, 11 factorial
Okay, then
over 4 factorial.
4 factorial for what? What?
Sir, 4 factorial for 4 L's.
Okay, and then bete?
And 2 factorial for 2 A's.
Okay, and then
And 2 factorial for 2 O's.
very good, beta. So this is 11 factorial over 4 factorial into 2 factorial into 2 factorial. If anyone has again any problem, please get it clear. Okay. Now you can do that second question yourself. Do all parts of the second question and then I'll ask you if you have done that correctly. Okay, after completing this second question, we are on to the third question. It says, a girl has 20 plastic squares. There are 5 identical. Now you look at, focus on this word identical, red squares, 7 identical blue squares, and 8 identical green squares. Okay. So identical means like, we had identical digits over here. We had identical letters over here, okay? So he says, by placing them in a row, join edge to edge, find how many different arrangements she can make using one square of each color. Okay, Samiha, bete, any idea if she is going to use one square of each color? So how many different arrangements she can have?
So 5p1 into 7p1 into 8p1.
Okay, 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 okay. Yes, then Nozaina, what would you say about this 3A? Yes, Nozaina, beta, we have to be quick. Nozaina. Muniba, 3A.
Um, sir, I think 20 factorial over 3 factorial.
अच्छा एक चीज देखें. If you are saying, please note it down, okay? If you're saying 20 factorial, that means you are arranging 20 cards. How many cards you're going to arrange in this 3A? How many cards you're arranging in this 3A? Are you arranging 20 cards or just 3 cards?
3 cards.
Three. Okay. So you already have one of those 3 colors in your hand before you're going to, it says one square of each color. So that means you have one red, one blue, and one green. So it is just like, suppose you have 3 letters, R, B, G. So in how many ways you can arrange this R, B, G?
6.
That is
3 factorial.
3 factorial. That is simply going to be 3 factorial. Please object here, argue here if you are not clear. This is going to be 3 factorial. I am going to move on to the B part. Please make sure that you're clear that why this is 3 factorial. Okay, now it says the 5 red squares only, 5 red squares only. Yes. Mariam Ali, what would you say about this 3B? The 5 red squares only. Yes, Mariam
Sir,
Ali.
wouldn't it just be one arrangement?
Exactly. This is one arrangement because obviously there are 5 red cards. How would you arrange them, Hannah? Like, whichever you keep first. So, that would mean, okay, it is going to be same. Like, for example, I can show you, I have, mashallah, all this arrange, I mean, this these tools here with me. Okay. Now suppose these are like, there are 5 circular red cards I have. Okay. So whichever I put first, or I mean after, in the middle, or wherever, this arrangement would look like the same. So that means it is going to be the same arrangement. Okay. So you can either answer this mentally, or you can, if for example you say, no, I have 5 cards, so I have to write 5 factorial. So if you write 5 factorial, you will have to divide it by 5 factorial, because all of them are same. And again, for example, if you have 5 times the letter R, so how many different words you can have from these 5 letters? So whichever R you write first or after, the word is going to remain the same. So that is why the answer is 1. There is just one arrangement if you have 5 red squares only. Okay, if you have anything in your mind, please open up, throw it out. Okay, get it clear. Okay, then we have Jazila. Jazila, beta, can you tell us about the C part? All of the blue and green squares.
15 factorial over 7 factorial into 8 factorial.
There were blue. How many blue we have? 7. And we exactly, beta. You are perfectly all right, because now we have got 15 cards with us. Okay, so 15 factorial and divided by, there are 7 blue. They're all same, and there are 8 green. They are all same. So this is going to be 15 factorial over 7 factorial into 8 factorial. And then it says all of the 20 squares. Okay, let me ask from, yes, Farheen Bete, all of the 20 squares.
Sir, I'm not sure, but 20 factorial over 5 factorial into 7 into 8.
Exactly, this is the right answer, beta. That is the right answer, because now you're going to arrange all 20 of them. So this is 20 factorial, and then you have the 5 red, you have 7 blue, and you have 8 green. So that is 20 factorial over all of this. Okay, we are going to move on to the 4th question.
Sir,
Yes, Peter.
why can't we just do 20 factorial like we did in 8? हमने सिर्फ 3 factorial लिखा था ना?
Yes, very good question, beta. How many cards you were arranging in part A?
1. Like 3 of
3. And
each.
out of those 3, how many of them were of the same color?
एक.
So they were all different. So we don't need to divide this 3 factorial with anything. Okay. Now look at this D part. How many cards you're arranging?
20.
So you have to have 20 factorial. And out of those 20 cards, how many of them are same?
5, 7, and 8 of
Yeah.
each color.
Yeah, so that is why we have 5 factorial, 7 factorial, and 8 factorial.
ठीक है, thank you, sir.
Okay. So when you divide these, like, when you're dividing this 5 factorial and 7 factorial, so that means you're canceling out those repetitions, which are increasing the number of arrangements which don't have to be there because of the same things recurring, okay, happening. Okay, let's go on to this next question, number 4. And now I'm going to clear this and we move on to the 4th question. Okay. Yeah. You try these 4, 5, 6, 7, and then I come back to you guys. Like, is there anyone who wants to discuss like about this 4th question, that which one of these are right and why? It says 2 students are asked to find how many ways there are to plant 2 trees and 3 bushes in a row. The first student gives 5 factorial and the second gives 5 factorial over 2 factorial into 3 factorial, and that is 10. Decide who you agree with and explain the error made by the other student. Yes? Anyone?
Sir, is it the second one?
Okay. Is there anyone who thinks the first one is right?
Sir, उन्होंने question में बताया नहीं है कि if they're identical or not, तो I think first student सही होएगा.
Now, please remember, this is really very, very confusing. Now, for example, if I say that, these trees are the mango trees, okay? 2 mango trees and 3 bushes are, for example, these are roses bushes, okay? So, do you think, now if you are now clear that these are 2 mango trees and these are 3 bushes, I mean rose bushes, so which one do you think is correct now? Is this 5 factorial the correct answer, or this 5 factorial over 3 factorial into 2 factorial? That is a
Second one.
Mhm.
So the
Yes,
second one.
second one. Okay, now let me tell you, the first one is the correct answer, because even if you have 2 mango trees, but every mango tree is different from and the other mango tree. For example, if it said that there are 2 boys and 3 girls, there are 2 boys and 3 girls. So would that be like you're arranging them in a line, 2 boys and 3 girls? So would you say 5 factorial or 5 factorial over 2 factorial into 3 factorial? Yes. Which answer is right now? That is the, yes, Fareba? Which answer do you think is right? Laiba Tariq? Maha Humayun?
Sir, 5 factorially.
Yeah, 5 factorial is the right answer. Okay. Now look at this question number 5. This should be our last question. Okay. It says 10 coins are placed in a row on a table, each showing a head or a tail. How many different arrangements of heads and or tails are possible? Yes, very tricky question. Okay, before you answer this A part, you can answer the B part first. Okay, it says of the arrangements in part A, find how many have 5 heads and 5 tails. So that would be 10 factorial over 5 factorial into 5 factorial. Yes? There are 10 coins, 5 heads, 5 tails. So shouldn't this be 10 factorial over 5 factorial into 5 factorial? Kubai?
Yes, sir.
So now look at this, more heads than tails showing. Okay, so I'll have to go back to the A part. This has very long working, this A part. Okay, and please make sure that you understand what is going to happen here now. Okay, now there are 10 coins. Now when you are tossing 10 coins or you're placing 10 coins, you don't have any, like, you're putting them at random regardless of what is going to be shown on that coin, either head or the tail. Okay, so you see, you can have all heads. Okay, you can have all tails. You can have 1 head, 9 tails. You can have 1 tail, 9 heads. You can have 2 heads, 8 tails. है ना? यही हो सकता है ना? 2 tails and 8 heads. You can have 3H, 7T. You can have 3T, 7H. You can have 4H, 6T. 4T, 6H. You can have 5 heads, 5 tails. Okay? Yes? And you find this, okay? Like you find this and you double it, okay? You find this, you double it. You find this, you double it. You find this, and plus this. So 1H and 9T would be 10 factorial over 9 factorial times 2. Because if it is 1 head, 9 tails, or 1 tail, 9 heads, the working would be the same. Yes or no? Yes, bachcho.
Yes, sir.
Yeah, huh? Okay. So similarly for 2 heads and 8 tails, or just, I mean, it would be showing same as 10 factorial over 2 factorial into 8 factorial. So you double that because of these two situations. Okay. And similarly, you find all of them, you add all of them, that would be the answer for this 5A. This 5A. Okay. And it says in 5B2, more heads than tails. So for more heads than tails, you will only consider these cases. There are more heads than the tails. Okay. I have missed one thing over here. No one told me about that. I missed 0 tails and 10. Oh, how can I miss that? And 0 heads and 10 tails. I just missed that. Okay, so you add that as well. So that is going to be 10 factorial over 10 factorial times 2. That means all heads or all tails. ठीक है बच्चों? So this is going to end our session. Today's session. We'll be moving into more complicated questions in our tomorrow's class. Okay?